Good morning, everyone. This is Angie over at Beyond the Lecture. And today, this is a do-over. I did not have my microphone on when I did my first video, so I get to do this over, but it's fresh in my mind, so I'm going to go through it a little bit quicker for you all. And before I get started, this video is on stoichiometry, and it reviews the problems, the typical problems that you'll see. So you'll see a variety of problems within this particular part of chemistry, and it's pretty extensive, meaning you'll see it over and over again, working with different types of chemical reactions. And as always, the sheet is on my website. Just click the link in the video description, and you're able to see the review sheet and follow along if you'd like during the video. Some noisy birds today. Okay, I'm going to go ahead and get rid of my face. All right, so to start off with stoichiometry, it is the review of quantitative relationships between reactants and products. So whenever I see this keyword here, quantitative, that means math. We're going to be dealing with numbers here. And it's based off of the law of conservation of mass. So this is critical when you're dealing with balanced equations. You need to make sure the number of atoms on the left matches the number of atoms on the right. So we already went through that on balancing equations. And number two just explains that balanced equations are like the recipe. It's like a cookbook recipe that you're dealing with here when you're taking reactants and making a product. I'm sure I'm not the first one to say that, but I'll go ahead and use that analogy. And we need to make sure we have the correct coefficients for the recipe so we can ensure that we're getting the correct results, either on the reactant side or the product side, depending on what we're doing. And speaking of reactants here, number three, we're going to talk about reactant matching. So you can be actually given an amount of one reactant, and you need to determine how much is needed for the other reactant or another reactant. There could be multiple, more than two reactants. And we make the assumption that we need at least, if we're given one amount of the reactant, we need at least enough of the other to cover it. And again, that depends on your cookbook recipe. So I'm going to start off with a very simple, I use this the first time around, I'll keep going with it. The formation of NaCl with sodium and the chlorine, molecule of chlorine. And so what we're saying here, I'll go ahead and draw this one in as well. So what we're saying here is that if we have two atoms of sodium, one chlorine molecule, we'll get two NaCl or sodium chloride molecules, formula units. And we can also look at that from a macroscopic level as well. So the first example I gave you is just microscopic because we're dealing with atoms and molecules and things like that. But remember, we can scale things up and say we have 2 moles worth of sodium, 1 mole worth of chlorine gas, chlorine molecules, and then as a result, we'll have 2 moles worth of sodium chloride. All right, so here's a quick example. If I say I have 4 moles of Na, and I want to know how much chlorine do I need here? How much chlorine do I need? And this is where we apply molar ratio. It's usually the first thing you do, these types of problems. You have to have moles first. So if you're given grams or maybe liters of gas at STP, you need to do a quick conversion and move it over to moles. We'll skip that part for now. But what we're saying here is if I have 4 moles of sodium, given our balanced equation, I know for every 2 moles of sodium I have, I also need 1 mole of the chlorine. And just like when we're doing conversions, make sure your units cancel. So in essence, we're taking 4 divided by 2. So we need 2 moles worth of the chlorine to make this work. So again, they're going to give you an amount, right? We don't know what that is. Read the question. All right, we have 4 moles of sodium, and I know for every 2 moles of sodium, I only need 1 mole of chlorine. So we're in essence cutting it in half. Should make sense. And in this situation, we need 2 moles worth of chlorine atoms. And by the way, I'll save this filled out worksheet on the website as well. All right, product prediction. So on number 3, we just matched reactants, but here we can take it a step further and determine how much product we get. So I'm going to carry on with the sodium and chlorine making the sodium chloride. If we have a certain amount of reactant, we can determine how much product is formed. Now here, if they only give you one reactant amount, you can assume you have enough of the other reactant to cover it. So at least enough to cover it or be in excess. Okay, that's the key term here, excess. So again, if I say Na plus 2, no, it's 2. It's 2 Na, and then 1 chlorine atom will give us a 2 NaCl. So if I ask, and this, I'll just give out a scenario here. If I need, no, I apologize. If I'm given, say, 5 moles of Cl2, how much NaCl will I get? And I'm just going to do moles. We'll just work with moles here for simplicity. All right, so I go to my balanced equation and I say, well, for every 1 mole of Cl2, I know I'll generate double, or 2 moles of, got ahead of myself, 2 moles of NaCl. All right, purple's my color today. All right, so make sure those moles of Cl2 cancel. So I know I will be generating theoretically 10 moles of NaCl. So we're going to double. We're going to double those results. For every 1 mole of chlorine I put in, and I'm assuming I have enough sodium to match that, I will generate 10 moles of sodium chloride. All right, so now we get into 5, 6, and we also have one more topic here in addition to that. So we're on the downhill stretch. We can be given 2 amounts of reactants, and they're not always going to match. All right, so I'm going to give you an example here of what that would look like. But whenever you're given 2 amounts of reactant and you're told to find out how much product you get, you should automatically think limiting reactant here. Why? Because we don't know. You have to do further analysis. We don't know if given one product, we have enough of the other to cover it, and vice versa. So the key here, and again, I'll use moles as an example. You could be given grams. As a matter of fact, the sample problem that I give after this video gives grams. We're given a certain number of grams of aluminum and a certain number of grams of oxygen, and you need to determine product from that. All right, so we'll stick with moles here. So I will use Na plus, of course, 2Na plus Cl2, 2NaCl. And I'm going to say, all right, I have, start off with 5 moles of Cl2 and 15 moles of Na. All right, so I'm throwing these numbers out here. So you've got to recognize first, I have 2 amounts. I need to figure out if one runs out, will I have enough to cover on the other reactant, okay? And so this one is probably a bit easier. You could actually look at it and say, well, because it's a 1 to 2 ratio, for every 1 chlorine molecule, I need 2 of the sodium. So I will look at that from a quantitative aspect. 5 moles of Cl2. For every 1 mole of Cl2, I need 2 moles of Na. Aha. So I technically need only 10 moles of Na, 10 moles of Na. 10 moles of Na. All right, do I have 10 moles? Yes, I do. I actually have 15, right? I have 15. So what we now know is that when chlorine runs out, the reaction stops, we'll have some extra Na left over. And that would be number 6. That would be number 6. And I actually did part of number 6 and number 5 because I was doing the upfront analysis. And it says in number 6, calculate how much of the excess reactant remains after the reaction is complete. Well, we take what we have and subtract what we need, and we have a difference of what's left over. So we basically take have minus need, and we'll have 15 minus 10 equals 5. We have 5 moles of Na left over. All right. Yep. Key concept, subtract the amount used from the original amount given. All right. And I'll actually flip this around here. So if I started off with 15 moles of Na and I wanted to see how much Cl2 is needed, I would say for every 10 moles of Na, yeah, getting tongue tied, I need 1 mole of Cl2. Okay. So 15 over 2, that's 7.5 moles of Na. And you could go back and say, I have 5 moles, but I need 7.5. That's an issue. That would tell you you don't have enough chlorine to cover the Na or the sodium, and you would still say that the sodium is limiting. Okay. And I ran out of room here, but I always put like a little note saying, okay, this is my limiting reactant, Lr, so I can go back and I won't forget. Okay, so we've determined what reactant is limiting, how much we'll have left over, and then we're going to look at percent yields. So that equation is down here on that next page. It's simply saying, okay, I'll have a result from a lab experiment, or they'll give it to you on the quiz or the test. They'll give you an amount. They'll give you a reaction and say, hey, we ran this in the lab and we have this much product. What is our percent yield? You would need to go through these steps to figure out, okay, how much should I theoretically get on my product? And so I've only determined again what the limiting reactant is and how much I'll have left over on the excess reactant, but I need to find out product. So remember, you always, always, always want to use your limiting reactant to determine product. Because when that's gone, everything's gone. If you use the wrong reactant, you'll have too much. Okay, I'm adding a second conversion here because I'm going to write train tracks here. These are just train tracks to separate my ratios. And if we start with our given 5 moles of chlorine, I know for every 1 mole of chlorine, I'll get 2 moles of NaCl. And was it 58.5 grams? Pretty sure that's the molar mass. Okay, so these little, we call them train tracks in chemistry. I would say a good number of teachers teach this trick, and it's just taking our given quantity of chlorine, doing our ratio on top here, and then of course that result will only give us moles. We can actually convert to grams here. Okay, and you can do that, for instance, with gas. You can have so many moles of gas and switch it over to liters. Just depends on the scenario. But I need to do a quick calculation. I'm going to have quite a bit. I'll have 585 ACL. So if I ran this, for instance, an experiment in the lab, and say I only generated 400 grams. So I'll just put down here lab result, 400. Uh-oh. And it is not uncommon to get a low amount in these labs. it's just not theoretical. So when we do stoichiometry, that's our ideal, in the perfect world, but it's not perfect. There's error all over the place. All right, so I'm getting roughly, it's like 70%, 68.4. Okay, so lab results divided by your theoretical, that's from stoichiometry, and you'll ultimately have a percentage there to work with. So that's not bad, actually. 68% is not that bad. So there you have it. This is an example pretty much from, what is it, 5, 6, and 7, what a limiting reactant problem would look like, where you're given 2 amounts, given an equation, make sure it's balanced. Of course, always make sure it's balanced. Use the appropriate ratios, because not everything is a 1-to-1 ratio. You might need 3 moles of something to match 1 mole of something, okay? In your cookbook formula, your balanced equation is going to tell you that, to apply that correct ratio. Excess reactant, that's just taking what you have versus what you actually need. You should be, you should have way too much, right? And so you just take that difference and figure out how much you have left over and put it in the correct units. I just use moles here, but you could use grams as well for the sodium. And then doing your percent yield, just determining how much you should ultimately get in your product using your limiting reactant, that's your LR right there, and determining that amount, taking your lab results. This is a given, especially in a problem. They'll just say, hey, we have this X amount from the lab. Tell me what my percent yield is. And we'll say 68.4 is your percent yield. On this particular question, just take lab, divide it out by theoretical, times 100. There you have it. So like and subscribe if you'd like to see more videos as they come out. I'm putting them out pretty much every other day. Please email me, text me, message me, send a Morse code. I don't care. Just let me know if you want to see additional content on this or any other topic that might be giving you trouble. And thanks again for watching.